Okay, guys, on this same worksheet, the bottom three that have to do with Charles' Law, I'm going to work through those really quickly. Let me give you a tiny review. Charles' Law has to do with volume and temperature of a gas. Okay, this is the formula. It's on the back of your reference page. Inside the combined gas law, you'll see a V on the top, a T on the bottom. So you can split that up, take the P out. V over T equals V over T, and that's Charles' Law. First off, this is a direct relationship. Boyle's is indirect. This is direct, meaning if one thing goes up, the other will go up. If one thing goes down, the other automatically goes down. So one thing you have to remember, this does involve temperature. Gas laws only work if the temperature is in Kelvin. Your problem, I promise you, is going to give you temperatures in Celsius. You need to change them over to Kelvin before you start plugging and chugging. So let's read number one together. I have 45 liters of helium. So 45 liters. Liters is a volume unit. At 25 degrees Celsius. So I have to take 25 and turn that into Kelvin by adding 273 to it. So if I do that, I'm going to get 298 K. My second volume, let's read my problem. I increase the temperature of the balloon to 55 degrees. What will the new volume be? So volume is what we're looking for. You increase the temperature to 55 degrees Celsius, but I've got to change that over to Kelvin. So plus 273 to give me Kelvin. I'm going to add that. That's 328 Kelvin. So now this is our new problem. Okay. We're going back to like 5th or 6th grade, right? We're going to learn how to cross multiply. How am I going to set this problem up to solve for this number? Well, I'm going to do it this way. I'm going to cross multiply. This and this get multiplied together, and you set them equal to this and this multiplied together. Let me show you how that works. It's 45 times this, whatever's on top here, multiplied by whatever's on bottom.
No. I got
and then this
it's 9.
Multiplied by this.
No.
Shh. Stop. So now we've cross multiplied. You set these two equal to each other, or multiply equals these two multiplied. Okay, that's why it's making a cross. You're cross and you're multiplying, right? Now, same thing as before. I got to get V by itself. It's what I'm trying to solve. So I divide to get rid of that. Whatever I do on the right, I must do on the left. And now I just work it out. 45 times 328. Hit the equal sign. And then divide by 298. And I get my new volume to be 49.5 liters. Make sure you're checking your units. Your original volume is in liters, so your new volume must be in liters, right? Make sure you're checking your answer choices that the units match. Let's see if the law holds true. Charles actually is a law, Charles' law. Let's see if the law is correct. Our temperature went from 298 to 328, which means it increased. Did our volume increase? Yes, it went from 45 to 49, so our volume went up as well. So the law held true. Let's work number 2. Now, when you're reading the problems on the end of course, you may or may not realize, okay, how do I know if it's Boyle's or Charles? How do I know which one I'm using? You're looking through your problem to see what units you're given. So if you read number 2 with me, it says I'm given 25 liters, which is obviously a volume. Liters is a volume. Of carbon dioxide are collected at 1200 degrees Celsius. Well, degrees Celsius is obviously a temperature. Let's keep reading though. What will the volume be? It's asking you to solve for volume of the gas after it cools to 25 degrees Celsius. And there you're given a second temperature. So if you've got 2 volumes and 2 T's after you read through your problem, that's obviously Charles' Law. So let's plug and chug. Number 2, 25 liters at 1200 degrees Celsius. Now I'm going to go ahead over here, 1200 Celsius. I need to add 273 to that to get that into Kelvin. What will the new volume be if the temperature cools to 25 degrees Celsius? I'm going to go over here, 25 plus 273, and convert that to Kelvin. It's a big drop. The temperature went from 1400 down to 300. So let's see what happens to our volume. I'm going to cross multiply times this. Set that equal to these 2 guys. These 2 guys multiplied. So the volume times 1473. I've got to get the volume by itself, so I divide by 1473. Whatever I do on the right side, I must do on the left. So now let's work this out. 25 times 298 gives me 7450 divided by 1473. And I get 5 liters. I rounded to a whole number, 5 liters. So yes, big difference. I went from 1473 Kelvin to 300 Kelvin, which means my volume dropped from 25 liters all the way down to 5 liters. So that's a direct relationship. That means the law holds true. Okay? Last one, number 3. I have 130 liters of a gas in a piston at a temperature of 250 Celsius. So I've got to come over here, add 273, and that gives me my Kelvin temperature. If I cool the gas until the volume decreases to 85 liters, right? Just check your units. That'll tell you where it goes. Liters is a volume, so that's your volume. What will the temperature of the gas be? So now you're solving for the second temperature. Same thing, you're cross multiplying. So you multiply 130 times what you're looking for, your temperature. Set that equal to these 2 multiplied together. 523 times 85. The rules of math still apply. It's basic algebra. You got to get T by himself. That's what you're trying to solve for. So you do the opposite function. Here you're multiplying. You got to divide to get rid of that. Whatever you do on the left side, got to do on the right. So now we're going to multiply 523 times 85. I got 44,455 divided by 130. And I get my temperature to be 34.196, which is about 342 Kelvin. Now, a common question. When I work this out and solve for temperature, will it be in Kelvin or will it be in Celsius? It's based on your unit here. Because you did the math right here, you converted Celsius to Kelvin and you used Kelvin in your problem, your answer automatically ends up in Kelvin. What your question might ask you to do is give me the temperature in Celsius. That's common because we measure temperatures in Celsius using a thermometer. We don't measure in Kelvin. We do math in Kelvin. So if your end of course question says, okay, here's the information I'm giving you, but I want the answer to be in Celsius. Well, all you would have to do is subtract 273 to get that back in Celsius. So just read your question carefully. Look at your answer choices. If all of your answer choices are in Celsius, it's expecting you to know to do that. Take Kelvin, change it back to Celsius for your final answer. And that's Charles' Law.